So this will be your review for your first four sections of Amatrol. They include an introduction to electric motor control, manual motor control and overload protection, control transformers, and control ladder logic. So when you begin this, I suggest you go through here and review. You don't have to do the whole sections, but I suggest you go through the self-review and maybe take the quiz again. We've already recorded grades on these, so if you run out of quiz retakes, if you will message me, I will clear them off for you. So this will be that test. The test will consist of 50 questions, multiple choice and true and false. And each question will be worth 2 points for a total of 100 points on this test. And I will go through there. I've kind of hand-picked all the sections out of here, so not all of the questions in the review will be on there. I've kind of went through, and some that I felt maybe were a little confusing, or I didn't like the wording on them. I didn't put them in the test. So let's go through the review. So one of the things you need to know is, how do we determine the output voltage of a transformer? Well, we determine that by the input ratio, or the input voltage and the turns ratio. And so if I had a turns ratio of 1 to 2 and I put in 50 volts, then I would have 100 volts out of the secondary. If I had a turns ratio of 2 to 1, stepping down, if I put in 50 volts into the primary, I would get 25 volts out of the secondary. One of the things we also need to remember, there's a question, and I know it was in there, but the NEC requires that if you have a voltage above 50 volts AC, we need to bond that neutral to ground. Remember, we've been doing that in the labs. Remember how transformers are rated. They're not rated in watts or amps. They're rated in volt amperes because of the fact that that rating applies to both the primary and secondary side of that. You need to review the part about a time delay fuse element, time delay fuse, and know that it has multiple elements in there. Remember that we can't use a white wire as a ground, even though we had that discussion about a sub panel, that you must go all the way back to where the green bond is actually going to the stake in the ground or somewhere to ground. But we can't, even though a neutral wire is technically bonded to ground, we can't go there. It's a safety procedure. We want to go all the way back to the breaker box before we ground. Remember the difference between, remember I talked about the NEMA style overloads and the little solder that melts inside the tube that allows the little gear to change. So remember that portion. Remember how magnetic overloads work. So we have like a little coil floating in oil and a little valve to let the oil pass through, and so we can actually delay those magnetic overloads, those dash pots. That allows us to adjust the response time. And then of course we need to know a contactor uses a magnetic coil to open and close. Now the logic elements, I will let you have your handout that describes it, because the wording on the test basically says, you know, if I have two normally open switches in series, what is that? Or logic is formed by, you know, two normally closed switches in parallel. So you'll need to review that. I'll give you that sheet, but you'll need to be answered that to know the 6 logic elements on the test. And those are here. Right here, 6 logic elements. So remember what they are. Let's zoom out just a little bit so we can see all of them. We have the AND, we have the OR, we have memory. Notice the stop button is in front on this one, but that's memory. And then we have a NOT, we have a NAND, and we have a NOR. So remember those logic elements. You're going to be questioned on that on the test. Know the components of a ladder diagram. We have inputs, outputs, we have the rungs and the rails, and then we have the wires in between. Remember the deal about ladder diagrams too, that for example here we only have one output per rung, so if we want a second output we can't put it here. We have to draw a parallel branch down here. Let's see if we can get the marker working, and we'll put another coil here and then we'll come back up. So make sure we don't want to put a coil over here because this actually causes a voltage drop if we put 2 of them in there, so remember that. Remember the difference between the different types of diagrams. We have our ladder diagram that we primarily control logic with. Our power diagram actually shows our power, high voltage power on everything, or it could show maybe a pneumatic or hydraulic schematics on it. Then we have a schematic diagram which actually tries to show component placement. There are 10 questions that are built similar to the Nameplate quiz, where you have maybe 2 switches, either they're in series or parallel, and it asks that if I push number 1 push button, what will be the status of the red light and the green light. So you have to know that. Basically we're testing the ability to read ladder logic. So there are 10 questions where you'll have a picture with a rung, and it says if I push number 1 push button, which lights will be on. If I push number 2 push button, which lights will be off, etc., etc. Know the some of the things about an electrical schematic. Components are represented by a standard symbol. Of course, they're helpful in troubleshooting a circuit, and basically the schematic shows all components in a circuit and how they are connected in a relative position. So think about all the things we can check in a transformer with an ohm meter. We can check the ground. We can see if the coils are shorted. We can see if there's shorts between the coils, or we can see if a coil is open. And of course, a transformer uses the principle of mutual inductance to transfer that electrical energy from one coil to the other. They're not actually touching. And I suggest you go over the section about motor sizing. Remember that we have to size a motor, and how we size it. We size it to the rated full load current of the amp. Okay. So we have to know what that is, and if we're sizing over current protection, we typically go to 125%. Depending on the torque load of the motor, we're allowed to go up to 140%, but typically 125. But we need to know that we do size that overload protection off the motor nameplate or rated full load current of the motor. You also need to know about earth bonding to ground. Basically, if it involves electricity and it is metal, somewhere it should be bonded to ground. Also know about lockout tagout. If you put a lock on, you're the only one that's supposed to take it off. Know about the different types of faults. For example, a ground fault is when one of our phases becomes grounded. Who maintains the rules of installation for electrical systems and equipment in the U.S.? That would be the NEC, or National Electric Code. I'm going to let you look this one up. Three-phase power, you need to know that how many degrees apart the three-phase is with a, so you can probably figure that out if you got three phases and we look at it in 360 degrees, how far apart are they? They're equally distant apart. Review the nameplate data. There's a video I showed you. I'll post it in our channel, but basically you need to make sure that you can identify a nameplate of a motor. Also about how much output power a motor can safely produce above its rated output power, that is be its service factor. Remember we talked about the reason we run a dual voltage motor at the higher voltage, even though they are rated for the same horsepower. We get less current draw, which means less heat, better efficiency, and so it also means reduced operating cost. Remember the rules of electrical safety. Get all the metal jewelry off of you. Keep all your tools organized and clean. Work with one hand when possible, and always use the buddy system. Know the basic components for a motor installation. You have to have a motor controller, short circuit protection, and a way to shut it off. Know the functions of a motor controller. Basically, you know, we can use it for speed control, start-stop control, and reversing. Now you're going to go, well, how can we control the speed? Remember we talked about the Y delta configuration, a 12-lead motor, so we can actually have a different configuration of the windings to have a different speed control on a motor if we wanted to with a contactor, or if they have like a run or start winding, or a low or high winding. Some of them do, specialty motor. Know that the different types of overloads. We, of course, we have our solid state. We have magnetic that uses a coil to sense the motor current. We have thermal overloads that actually a little bimetal element heats up and it pops open. We also talked about how the NEMA is a little bit different, but they're all based on thermal. So, but if we're using a coil to sense motor level, that's kind of like a wig meter. We're using a magnetic coil, and those are only seen in magnetic overloads. And that's about it. We've covered the entire test.